Welcome back, Year 8. In this lesson, we're going to be looking at minerals. So minerals are the things that make up rocks. So it's a whole lot of different minerals put together is what makes a rock. So we're going to be thinking about what actually is a mineral. There are many different kinds of minerals in the world, and we'll be looking into a few of them in class. Here's a couple of common ones that you might have already heard of. We've got quartz is a mineral, talc, even gold. So some minerals are just straight elements that we see on the periodic table. Pyrite is a really interesting one, and you may have heard of this one being called fool's gold before because it looks a lot like gold. So sometimes people pick it up and think they've found a big nugget of gold, but it's actually just pyrite, which isn't actually worth that much. So it's not terribly exciting if you find pyrite, unless you're into pranking people, then it can be exciting. So what actually is a mineral? It's an interesting question. So we actually have 5 criteria that we use to classify something as a mineral. So it has to meet all of these criteria in order for it to be a mineral. So the first thing is quite a simple one. It must be a solid. So obviously something like, let's say, liquid water, that's not a solid. So it's not going to be a mineral. It also has to be naturally occurring, so not something that's man-made. So in terms of it being a solid, it needs to be a solid in its naturally occurring form, because obviously if we're going to heat something up, it's going to turn into a liquid. But in the state that we find it, whether it's within the Earth's crust or on top of the Earth's crust, it must be a solid there. It's also got to be inorganic. So this means it's not made from living things. It also can't be made from the remains of living things, and it's obviously not going to be a living thing in itself. The next thing is that it has to have a fixed chemical formula. So what that means is that it's always made up of the same type of atoms and the same ratio of these atoms. I'll show you an example. Quartz is a really common mineral. Now what quartz is actually made up of is, well, here's its chemical formula. It's made up of silicon and 2 oxygen atoms. All right, so quartz is always going to have that chemical formula. It doesn't change. Same with if we look at our fool's gold or our pyrite. That's actually made up of these atoms. So it's made up of, just get my pointer, of iron and 2 sulfur. So that's fixed, it doesn't change. It's not going to suddenly one day become 2 iron atoms and 1 sulfur. That would mean that it wouldn't have a fixed chemical formula and therefore it wouldn't be a mineral. The final thing is, with these atoms that it's made up of, they must be in a specific arrangement. So let's delve a little bit deeper into what that actually means. So what does a specific arrangement of atoms actually mean? Let's have a look. Put this up here. Okay, so we can think of, I guess, all chemicals being made of atoms that are in either a specific arrangement, like those of minerals, or in a non-specific arrangement. So if you're thinking of something that's in a non-specific arrangement, this means it's very chaotic. It's kind of like our science classrooms almost. And the atoms are just arranged at random. Whereas if there's a specific arrangement, they're very ordered, and all the atoms sit in their proper place. So if we look at a very simple diagram that depicts this, it would be this one. So you can see here, the atoms are very ordered. They're all sitting in nice tight rows. Whereas on this side here, it's chaotic. The atoms are just sitting kind of wherever they feel like it. So we would say this is not a specific arrangement. Here's another example. So both of these are made up of the same types of atoms. We can see they've got the pink atoms and they've got the green atoms. However, this one has them in a specific arrangement. Over here, they're just chaotic. They're arranged at random, you could say. A really great example about a specific arrangement of atoms is when we think about the mineral quartz. So let me get you a picture. So we already know that quartz is made up of silicon and 2 oxygens. So I'll get my pointer. Oh, one moment. Here we go. So quartz is made up of silicon and 2 oxygens. And you can see that they're arranged in a very specific order. So it almost looks like stars of all the atoms sitting together. However, glass, so if you're actually thinking about the glass that you see in your windows and in your cars, that's also made up of silicon and two oxygens. However, look at the arrangement. They're in a very chaotic arrangement. You can see down the bottom here, there's one section that's arranged like a star, like we saw in quartz, but the rest of them are just arranged at random. There's no order to it, which means that glass is not a mineral. Quartz is a mineral, even though they have the same chemical formula. So it's really important that in order for something to be a mineral, they have to satisfy all 5 bits of these criteria. So like we saw with glass, it had a specific chemical formula, however the atoms weren't arranged in the specific crystalline structure, therefore it was not a mineral.